Hello. All right, so I told you in class after I passed out the homework that we didn't have time and that we just needed to go online, check the PDF, and or watch the YouTube video. So we're going to go over the 10.1 practice, 12 through 22. Put me at 2 times the speed or skip through once you see that I'm on a specific problem if you don't need help on every single thing, because this is a lot of work. So, first one we're going to do is number 12. Number 12, our function was y equals 5x to the 5th minus x to the 4th plus 4x to the 3rd plus 2x plus 5. So we are in standard form because we see no parentheses and we're from biggest degree to the lowest. So what the instruction said was determine the y-intercept and the end behavior of the following functions. So for end behavior, we need degree and leading coefficient. Degree, we find in the leading term. We also find the coefficient, the leading coefficient there. So degree is the exponent, the largest exponent we have, which is 5. The leading coefficient is the number that's out in front, which is also 5. So the degree, what we care about is that it's an odd number. And then the leading coefficient, what we care about is that it's positive. So with that information, we can kind of say that it's going to look kind of like this. In class, though, we said it's just going to kind of act like a straight line with positive slope. So when we do end behavior, that says x goes to infinity, which is to the right, y would go to, so if we go to the right, it's going to go up. So that's also positive infinity. As x goes to negative infinity, y, so as we go to the left, y is going to go down. So y also goes to negative infinity. The instructions also ask to find the y-intercept. And for that, if it's in standard form, we just look at that last term. So our y-intercept is y equals 5. Or if you want to write that as a whole point, 0, 5. All right, so that's all we had to do for 12. This is just like the quiz that you took most recently. The next one, we have y equals 5x to the 12th plus 43x to the 8th minus 14x to the 5th plus 12x to the 2nd plus 8x. If you tried to graph this, your calculator would probably get mad at you and just wouldn't do anything. So it's in standard position, so again, standard form. So again, what we need to use is the degree and leading coefficient. So our degree, we're looking at that biggest exponent term, which here it's already in order, so our degree is 12. Our leading coefficient is again 5. Here, so now we have an even number, but our coefficient is still positive. So for an even number, especially for a degree that big, this is why there's a whole bunch of turning points, but end behavior is going to act just like a parabola. And the positive means that it's going to be facing upwards. So for our end behavior, as x goes to the right, we can see that y will go up. As x goes to the left, our y will go up as well. Y-intercept, again, we're looking at that last term. We have to be careful here because there is no number that we're adding. So if we added that in ourselves, we would have 0. So our y-intercept is y equals 0 or just 0, 0. So this one will go through the origin. Next up, let's do the next section. So we have 14. And here it's saying use what you know about end behavior and zeros to graph the following functions. That is just a sketch. So if we have f of x equals x times x minus 5 times x minus 3 times x plus 2 times x plus 4, there's some things that we can look at this real quick. First, we have 1, 2, 3, 4, 5 factors here. So our degree will be 5. our leading coefficient, we're going to take all the coefficients that I'm trying to highlight, we just don't see any, and multiply them together. So our leading coefficient is 1. And then for our y-intercept, we take all of our factors and multiply them together. Trick is, there is one right here. So we would do 0 times -5 times -3 times +2 times +4, which will just be 0. And then our x-intercepts is when we take the opposite of what's inside the parentheses. So here we have +0, so that means we have 0. Next one, we have -5 inside the parentheses, so +5 if we flip it, and so on. So when we graph this, we need a y-intercept of 0. We also have an x-intercept of 0. And then we have one at 5, one at 3, one at -2, one at -4. And we know our leading coefficient is positive. So we're going to come up from the bottom left. And then we know we have to come back down. And then we know we have to come back up. And then we have to know we have to come back down. And then we have to know we have to come back up. We're not being precise here. This is just a sketch. So we just want the key features in there, which we cross the y-axis at the correct point because we crossed at 0, and we cross the x-axis at all 5 of those points. So we're good. 15 is similar, except for now we have some multiplicity. So now we have f of x equals x minus 3 squared, x plus 2 squared, x plus 4 squared. So to find our degree here, we look at all of our exponents inside and outside of the parentheses. And because those exponents are all 1 on the inside, all we do for our degree is 2 plus 2 plus 2, so 6. Our leading coefficient, again, we would take all the coefficients and multiply them together. So that's 1. Our y-intercept, we can either say that's at x equals 0, so plug in 0 to all of these and just calculate it. The shortcut, and that's going to be kind of tricky now because we have these exponents outside of the parentheses, we have to do -3 to the power of 2, +2 to the power of 2, +4 to the power of 2. So we're going to get 9 times 4 times 16. So if we do that, we get, and I'm using my calculator, and so we do 9 times 4 times 16, so 144. All right. All right. Next up, x-intercepts. Those are way easier. We just take the opposite of what's inside those parentheses. Okay. I just have this sinking feeling like I did not do that multiplication right. Which I did not. Okay. 576 for the y-intercept. All right, so now when we graph this, we have to go up to basically 600, right? We have only 3 intercepts, x-intercepts, which will be at -4, -2, +3. It's an even degree function, positive leading coefficient, so it's going to kind of look like that. But for our x-intercepts, we have a multiplicity of 2 for each. And when I talked about multiplicity, I said if it's an even number, I said it kisses the x-axis. All right, so because it's a positive even function, we're going to come down from the top left, just kiss the x-axis, come up, come down. We have to come back up to 600, come down to 3 at the x-axis, and come back up. Again, this is just a sketch. Probably not that similar to what it looks like in our graphic calculator, but that is our best sketch. All right, so let's move on to the next problem. All right, next up is going to be 16. 16 says factor and find the zeros. So hopefully we have some easy factoring here. So 16, we have f of x is equal to 4x cubed minus 3x squared plus 16x minus 12. So in our book, it said first try to group them up and see if you can take out anything from each. So if I look at those first two terms, I can't take out any coefficients, but I can take out an x squared, and I'm left with just this. The last two terms, we have 16x and minus 12. We can take 4 out of each, and we're left with 4x minus 3. Because these match, that means we can factor it. So we get x squared plus 4 times 4x minus 3. So that is the factored form of our function. And then it says go on and find the zero. So then we set each of those equal to 0. And then we hit this roadblock, right? So I have to take the square root of both sides. And then I have this negative inside the square root, which we said we can't do unless we start using complex numbers. So we get x is equal to plus or minus the square root of negative 4. So x is equal to plus or minus 2i. On the other side, we're going to get a fraction, but at least it's only one answer. So that's 16. So let's move on to 17. 17 is f of x is equal to negative x squared plus 2x cubed minus 9 plus 18x. This one is not in standard form, so let's rearrange it. 2x cubed minus x squared plus 18x minus 9. So again, try to group it up. Can't take anything out of those coefficients, so we just get 2x minus 1. Over here, it looks like we can take out a 9. So 2x minus 1. So again, because these match, we can group it up in another way. So x squared plus 9, 2x minus 1, and that's f of x in factored form. And again, we set these equal to 0 and then solve for x. So we get 2x equals 1 for this factor. So x is equal to 1/2. Over here, though, we get x squared is equal to negative 9. So if we take the square root of both sides, we get x is equal to plus or minus the square root of negative 9. So x is equal to plus or minus 3i. So those are our zeros. Let's move on to our next problem. 18, we have to keep factoring. For 18, we have f of x is equal to x to the 4th plus 3x cubed minus 18x squared. Notice how we don't have anything else. So we're going to try to factor out stuff from everything. I looked down here. I saw that my smallest exponent is a power of 2, so that's why I'm going to try to factor it out. And then my coefficient, the smallest coefficient, is a 1. So I definitely can't take anything out. So I'm going to take out x squared from each term. So I get that quadratic. So now I'm going to try to just factor the quadratic with our AC method. So a times c is equal to negative 18. B is equal to 3. So we're looking for two factors of negative 18 that add up to 3. That would be positive 6 and negative 3. So we get x squared, x plus 6, x minus 3. We have to do a little bit of work, but now we don't have to have these weird imaginary numbers. So over here we get x squared equals 0. So just x equals 0. X plus 6 equals 0. So x equals negative 6. X minus 3 equals 0. So just x equals 3. So those are 3 different zeros, but the x equals 0 would have a multiplicity of 2. So if we graphed it, we would see something that kissed the excess there. Next function, we get 2x to the fourth plus 12x to the second plus 16. So here, grouping doesn't work. Trying to take something out of each three terms isn't going to work. But we kind of see the same structure here as a quadratic. So first, at least, we can take out that 2 from everything. So at least the numbers will be smaller. So now we're looking for the factors of 8 that add up to 6. And that would be 4 and 2. So we have 2 times. We have plus 4 and plus 2. But instead of just having x, we're going to have x squared, because x squared times x squared is equal to x to the fourth. So when we try to find the values of x, we don't care about this anymore. We just want x squared plus 4 equals 0, x squared plus 2 equals 0, and then we just solve for x. So x squared equals -4. Take the square root of both sides. So x is equal to plus or minus the square root of -4. So x is equal to plus or minus 2i. On this side, similar, right? Take the square root of both sides. X is equal to the plus or minus the square root of -2, except we can't take the 2 out, but we can take the negative out. So we get x is equal to plus or minus I times the square root of 2. And I prefer the I first. All right, so those would be our 4 separate x-intercepts. So those were all the factoring ones. Now we have to graph 20 and 21. We're just going to try to do this with a sketch. So no reason to get too stressed out. So let's move on to 20. We have f of x is equal to x squared plus 4x plus 4, and then x minus 1. So our degree is equal to, then we look for exponents, right? And if we don't see them, they're 1. So if we do all of that, our degree is 3. Our leading coefficient, if we FOILed that out, distributed it out, we would get a positive 1. And then if we did the same thing for our last terms, we would get a y-intercept of -4. Right, so we can do that first. It's odd and positive, so it's going to look something like this. So now we have to think about our x-intercepts. We can find this one right here. That would be positive 1. But then we have to try to think, if we could factor this, what would we get? I'm thinking of 2 numbers that multiply up to 4, but also add up to 4. Does that exist? 2 numbers that multiply up to 4 that add, yes, it does. All right, so we get x plus 2 times x plus 2, which means we have x is equal to -2, but we have a multiplicity of 2. So we have -2, but multiplicity of 2. So if we do this now, we know it has to cross through at those 2 points only. It can touch the x-axis there, and it can only look like this. So what I just did was I kind of added it in so we can kind of see what's going on when I sketch this, because it's either going to have, we can only cross or touch the x-axis at 2 points. So it's going to be kind of funky. If we move on to 21, we have this not finished factored form, so or do we? So we have f of x equals x minus 1 to the third, x plus 1 to the second. So we have factored already, so we don't have to do anything like that. So we can look at the degree. We look at our exponents. I don't see anything inside, so our degree is 5. Our leading coefficient is positive 1. So again, we have an odd function that can look like this. Our y-intercept, again, is one of those weird ones where we have to take our exponents and that last term. So we have -1 to the power of 3 times 1 to the power of 2. So we have -1 times 1, so -1. And then our x-intercepts will just be the opposite. So 1, that will have a multiplicity of 3. And then -1, and that has a multiplicity of 2. So when we graph this, y-intercept is -1. We're going to cross at +1 and -1. And because at -1 we have the multiplicity of 2, we're going to come up from the bottom left, go up to the axis, and come back down. And then we need to go through the y-axis at -1, but now we have to figure out at +1 with a multiplicity of 3, it's going to go through. So that should be what our our degree 5 function looks like. Lastly, for number 2, we've been talking about it already. This was trying to get you to think about it. So make a conjecture about how the multiplicity of a root affects the graph of the function. So if multiplicity is even, the curve goes through x-axis. If the multiplicity is odd, and remember multiplicity just means the degree on the factor, the curve that we're graphing kisses, touches, touches but doesn't go through the x-axis. So that was the homework. Let me know if you have any questions. Sign up for seminar if you are here for seminars. Otherwise, send me an email or something else like that.